This is chapter 7, section 2. In this section, we're going to be factoring trinomials. All right, so when you're going to factor trinomials with a leading coefficient of 1, it'll be in this form, x squared plus bx plus c. We're going to factor out a common monomial factor and then factor the remaining factor, a trinomial with leading coefficient 1. All right, so I have some directions right here for you, but after we do a couple, then we'll talk about this rule, and it'll be a little easier for you. All right, so let's look at letter A, example 1, letter A. So basically, we need to come up with two binomials that when I multiply them together, I get this trinomial. Okay, so basically, we're looking for two numbers. When I multiply them, I get 12. And when I add those same two numbers, I get 8. So what are the factors of 12? Well, the factors of 12 are 1 and 12. There's no way to add or subtract 1 and 12 to get 8. We also have 3 and 4. Can we add or subtract 3 and 4 and get 8? No. But what about 6 and 2? 6 times 2, that's 12, but isn't 6 plus 2 also 8? That's what we want. We want two numbers. When we multiply, we get 12. When we add them, we get 8. So we know the two numbers are 6 and 2. So the square root of x squared is x. So we're going to divide out our x's. And then our two numbers that multiply to give us 12 and add to give us 8 is 6 and 2. All right, so we have factored this trinomial, and I'm just going to show you how you can check your work. All right, so if we FOILed these, we would multiply our first two terms. X times x is x squared. We would multiply our outside terms. 2 times x is 2x. We would multiply our inside terms. 6 times x is 6x. And 6 times 2 is 12. And then if we add those like terms together in the middle, we get what we started. Okay? So we have taken this trinomial and we have factored it out, and this, what I circled, is our answer. All right, so that's how you do all of these. You want two numbers that multiply to give you the letter C. So if this was in the form A plus B plus C, we want two numbers that multiply to give us C and add to give us B. Okay, this time we want two numbers that multiply to give us 12, but when we add them, we want to get negative 8. Well, once again, our factors of 12 are 1 and 12, 3 and 4, and 2 and 6. Well, isn't it true that it takes a negative times a negative to equal a positive? So if I multiply negative 1 times negative 12, I do get positive 12, but when I combine those, I would get negative 13. Negative 3 times negative 4 is negative 12 when I multiply them, but when I add them, I get negative 7. Negative 2 times negative 6 is positive 12, but when I add them, negative 2 plus negative 6, I get negative 8. And that's what I'm looking for. So this time, we're going to distribute that x. This time it's x minus 6, x minus 2. And I could have written it x minus 2, x minus 6. It would not matter. Okay? So this is our answer. And if I FOIL this, I'm going to go back to what we started with. Now I'm going to talk about this rule that I skipped for just a second ago. So basically this says if C is positive, then both factors must have the same sign. So remember, this right here is C. So if C is positive, it says that both of these numbers have to have the same sign. And they do. They're both positive. Then these rules say if C, number 2 says if C is negative, then one factor must be positive and the other's negative. So when C is negative, and we don't have an example of that. Right now we only have an example is if C is positive, then the two numbers have the same signs. These are both negatives. These are both positives. Okay, so that's true. When C is positive, your two numbers are going to have the same sign as each other. However, the rest of the rule says that when C is negative, like this one, you're going to have one negative and one positive, and this sign is always going to be the bigger of the two numbers. So we'll get to this in a minute. Now here, we want two numbers that multiply to give us 6, but add to give us -1. Well, if C is positive, then the two numbers will have the same sign. So what are the factors of 6? There are only 1 and 6 and 2 and 3. So could we add or subtract 1 and 6 to get -1? No. But could we put 3 and 2 together in a way that when we add them or combine them, we get -1? Yes. So when this is a positive number, it means that both of our signs have to be the same sign, and this is going to be the same sign. Well, let's see if this works out. So 6 is going to be -2 and -3. Now, do you agree with me that -2 times -3 is +6? That's true. But is -2 plus -3 -1? No, it's -5. Well, then we might think, well, then that means one of these has to be positive and one's going to be negative. So now does -3 plus 2 equal -1? Yes. But does +2 times -3 equal +6? No. This is not factorable. Okay? When our C is positive, these have to have the same sign. And if they are the same sign, this doesn't work out. So this is not factorable. Now letter B, our -20, our 20 is negative, which means that both of our numbers have to have different signs. We have to have one positive and one a negative. So the first thing we're going to do is break up that y squared. Now let's think of two numbers. When we multiply them, we get -20. That makes one positive and one negative. But when we add them, we get -8. Well, the factors of 20 are 1 and 20. Can't get 8 from that. 2 and 10. Can you get -8 from that? The other two factors are 4 and 5. 4 and 5 can't combine in any way to give us -8. So it's got to be 2 and 10. Now we want one of these has to be positive, one has to be negative. When we combine these two, as in if I put a plus sign between them, if I give 2 the negative, will this give me -8? Nope, it'd give me +8. If I put a negative in front of my 10, is that going to give me -8? Yes. So that means 10 has to be negative and 2 has to be positive. It doesn't matter if I wrote y plus 2, y minus 10. Doesn't matter about that order. But now, if I FOIL this, I'm going to get y squared. 2y minus 10y is -8y. And then if I multiply these, -10 times 2 is -20. So this is the right answer. I know I'm right. All right, so we're going to keep practicing these, but I'm just reminding you, if you'll remember these, this rule, this will help you figure out what's going to be negative and what's going to be positive. Okay, so if letter C is positive, both of the numbers have to be the same sign. Either they both have to be positive or they both have to be negative. If letter C is negative, that means one's positive, one's negative. And the biggest number is going to be whatever the sign of B is. So we're going to practice some more of these using that rule. All right, so let's look at letter A. Now, these two problems both have common factors. Before we break it down, we can divide the whole trinomial by the greatest common factor just like we did in our last section. So look at those three terms. What do all three terms have in common? What can we factor out of all three terms? Well, these can all be divided by 5, and they can all be divided by x. So we're going to pull out a 5x from each term. So 5x to the third divided by 5x. If I pull out a 5, 5 divided by 5 is 1. I had 3 x's, I pull out 1. That means there's 2 x's left. Negative 15 divided by 5 is negative 3. I had 2 x's, I pulled out 1, so I have 1 left. And then here I have 10x divided by 5x. Well, 10x divided by 5x is positive 2. Okay? So now I still have to factor this trinomial. I'm going to ignore the 5x. I'm going to completely ignore that now. And I'm just thinking, okay, I have to have two numbers. When I multiply them, I get positive 2. And when I add those two numbers, I get negative 3. Well, remember, if C is positive, that means my two numbers have to have the same sign. And the sign of B tells me what that sign will be. So the only factors of 2 is 2 and 1, right? 2 and 1 both have to have the same number. And this tells me that both of the numbers are negative. So x minus 1 and x minus 3. I'm sorry. I'm trying to get a product of positive 2. Now, does negative 1 times negative 2 equal positive 2? Yes. And does negative 1 plus negative 2 equal negative 3? Yes, so I know I'm right. If I FOIL this, I'm going to get this trinomial right here. Now, don't forget, this is part of our answer because we factored it out. Now, that trinomial has been completely factored. All right, letter B. Look at each of the three terms. What do they all have in common? Well, I can divide all three of those terms by the number 3. So I'm going to do that first. So 3x squared divided by 3 is x squared. 15x divided by 3 is 5x. And 18 divided by 3 is 6. So I have a trinomial. I got to break it down into two binomials. So I'm going to break up my x squared. There's 1x and there's 1x. All right. I need two numbers. When I multiply them, I get 6. When I add them, I get 5. If C is positive, that means my two numbers have to have the same sign, and this tells me what sign they are. Well, 6 and 1, that can't give you 5 unless you're subtracting, but we're adding this time because we have both positive numbers here, and the other two factors of 6 are 2 and 3. So it doesn't matter if I put plus 3 and plus 2 here. That doesn't matter. But now let's double check it. I need to get a product of 6. Does 2 times 3 equal 6? And I need to get a sum of 5. Does 2 plus 3 equal 5? Yes. So that is my final answer. All right. Let's try these 4. I believe these are from my Hawks. All right, let's look at letter A. First of all, I want to see, do all three of these terms have a common factor? And they do. They all have a 4x in common. So I'm going to divide every single term by 4x. So if I divide by 4, I get 1. If I take out one of these x's, I get 2 x's left. All right, 8 divided by 4 is 2. 2x divided by x is x. And then finally, negative 12 divided by 3, or excuse me, negative 12 divided by 4 is negative 3. X divided by x goes away. All right, now I want two numbers. When I multiply, I get negative 3. And when I add them, I get positive 2. I'm going to divide up my x's. C is negative. That tells me that my two numbers are different signs. And this is the sign of the bigger number. Well, the only factors of 3 are 1 and 3. So I have to put 1 and 3 down here. Well, this tells me the biggest number is positive. This tells me my signs are different. This tells me the sign of my bigger number. All right, let's double check it. If I multiply -1 and 3, do I get -3? Yes. If I add -1 plus 3, do I get +2? Yes. And then don't forget to bring down your 4x. That's the whole answer. Letter B, what do they all have in common? They all have in common 10y to the third. 10y to the third. So y to the fifth divided by y to the third is y squared. 10 divided by 10 is 1. -20 divided by 10 is -2. Y to the fourth divided by y to the third is y. And -80 divided by 10 is -8. And I took out all the y's. So this tells me I have two different signs. This tells me the sign of the bigger number. So I'm going to bring down my 10y to the third. I'm going to divide out my y's. I want two numbers. When I multiply them, I get -8. When I add them, I get -2. My only two factors of 8 besides 1 and 8 is 4 and 2. This tells me my bigger number is negative. So -4, +2. Double check it. Does -4 times 2 give me -8? Yes. Does -4 plus 2 give me -2? Yes. All right, letter C. I'm almost out of time, but let me try to get these done. The least common multiple is 5x to the third. So 5x to the third taken out of 5x to the fifth is x squared. -5 divided by 5 is -1x. -100 divided by 5 is -20. So I want two numbers. When I multiply them, I get -20. When I add them, I get -1. Well, the two factors of -20 are 5 and 4, because 2 and 10 won't work to get 1, but 5 and 4 will give me -1. This tells me my signs are different. This tells me my biggest number is negative. Does -5 times 4 equal -20? Yes. Does -5 plus 4 equal -1? Yes. I am done. Letter D. Do these all have anything in common? No, they do not. Now, the only way this is different is because this has p squared, so we divided it up. At the end, I have q squared, so we have to divide this up as well. And with it, we're going to think I need two numbers. When I multiply, I get 9. When I add, I get 10. Well, we're all probably thinking of 3 times 3, but 3 plus 3 doesn't equal 10. So the only other two factors of 9 are 9 and 1. This says they're the same sign, and this tells me the sign is positive. So I'm going to divide my 9q and my 1q. I would write a 1 there, but 1 times q is just q. All right, so let's FOIL that, see if we get this. P times p is p squared. P times q is 1pq. 9q times p is 9pq. And then 9q times q is 9q squared. If I combine like terms, 1pq plus 9pq is 10pq. And that's what I started with, so I know this answer is right. So if you have this last term is squared, just like we divide out the first term, you're going to have to divide out that last term. So that's the only way that this one's different from the others. All right, and that's it. I have a couple more sets of directions. You can pause. My phone's about to max out on my minutes. So if you want to pause and read that. And I have one more note for you. A polynomial is not factorable if it cannot be factored as the product of polynomials.